Oh hey guys, how's it going? So this is the second part in the kernel cheat series, and we're going to be doing the user mode client in this one. Now in part 1 we did the hook, which was in dxg-kernel.sys. We hooked whatever function we hooked, and then we did a basic move racks, jump racks, and that's what's going to call our hook function here. And basically we're going to use that in this video. We're going to make a little client here. What does that mean? It's just going to be an exe, right? And we're going to make a structure here for like our instructions, and then we're going to call the hook function with the instructions. Okay, that's very basic, but that's basically what we're doing. So part 1 was pretty advanced, that's why it was such a long video, and I feel like it was kind of fast paced, but in comparison this video is going to be much simpler. There's no disassembling, we're just going to be coding this one. All I'm doing is I'm just going to make a structure, and then I'm going to make a little hook function. I'm going to make a function to call the hook function, and that's pretty much it. We're going to be able to read, write, get a process base, whatever. So by the end of this, you'll be able to use the driver, and you could hack CSGO or whatever by the end of this video if you wanted to. So yeah, let's get into it. Alright, so we're going to be adding a new project. Okay, so we're going to add a new project here, and this is going to be our user mode component. So I'm just going to call it kernel cheat um. Alrighty. Alright, cool. So we've got our user mode thing here. Going to make the main. Cool. Alright, so let's start coding it. We're going to do the includes as usual. Cool, so that's what we're going to need. I'm going to show you guys the struct that we're going to be using to communicate. So it's going to be a type def. Cool. And we're going to need quite a few things in here. So first thing we're going to need is a buffer address. Then I'm going to need the actual address we want to work on, and the size, process ID, and then whether or not we want to read and write. What else? Whether we want to request the base address of the outputs, and then the module name for if we want to get the base address. So that's it, and then I'm going to make cool. So that's our structure there. You're going to want to copy this into the kernel thing, because you're going to need it in the kernel. Probably put it in here, right? Or maybe it should be fine. Cool. Alright, so you want to make sure you put it in your kernel driver. I just put it in the memory file. Alright, so because that can't be fucked, I'm going to make global variables, which is usually bad, but I don't really care. Static. Coolios. I don't know why that's static. That doesn't need to be static. So we've got our structure, global variables. Now we're going to do the hook function. And this is going to be pretty epic. So we're going to use the templates. Type name. Cool. Alright, so we got a template going. It's going to return uint 64. Holy shit. Yeah, cool. So we're using type name for the arguments so we can work on like whatever you want. There's jackets on my chest, so I'm gonna cool. Alrighty, so this is where we're gonna call the actual kernel hook. So we need to export the function. So the function that we hooked is in win32.dll, and if you used a different function, it'll still be in here. So basically any function that was in DXG kernel that we could have hooked right there, that I showed you in that page or whatever, it's going to be in this DLL. So you guys can, even if you hooked a different function, you can use the same DLL here. And in this parameter, you just want to put the function name that you hooked. So we did query composition surface statistics. But you guys can put whatever you did. But if you guys did a different function, you'd just put the function name in here and it'll still work fine. So this is where we're exporting the function. So we're getting the address of the function. And then we're basically doing a static cast, making a standard call, and then setting up our arguments here for the call. And then this is where we call the function with the arguments. So now we need the function to get a process ID. And I'm just going to use this function. I'm pretty sure it's from like unknown cheats. Yeah, I did not make this, but it works, you know? So cool. Alrighty, so I'm getting this string view error. Pretty sure it's because my settings are wrong. So yeah, so your language standard, you want it to be, I think, 17 or the one above. Yeah, there you go. Cool. Now this is the actual function where we get the process ID. So this is just for when we loop through the handles. We have a little like function here that's spelled wrong as well. So we got this operator function here, and basically it's going to help us cycle through the handles. So if it's not null, and if it's not invalid, then we close the handle. Yeah, cool. So this is where we're taking a snapshot of all the processes apparently. Okay, then we're going to say if okay, so if it's an invalid handle, obviously we don't want that, so we return null. And then we need to set the size of this. Cool. And this is where we're going to loop now, so we say process 32 next, or while process 32 next, with the snapshot handle. Why isn't it coming up? Cool. There we go, cool. So just copy the settings that I just did there, and it should fix all the errors. And then I think that's it for this function. We just need to do a little thing here. Return null if that failed. So this is just like any other like process ID function or handle function. It just takes a snapshot, loops through it, and then compares, is this the one that we want? And then returns the process ID, okay? I just like it because it uses this handle disposer thing, which is kind of cool. But yeah, I didn't make that, I copied it off unknown cheats or something. I don't know where I got it from. So the next thing is cool. Alright, so now we can start doing the like instruction functions pretty much. So okay, so this one's going to be for getting the module base address, and first thing we're going to need to create a struct of null memory, and I'm going to call it instructions, I guess. So this is like going to be instructions for our driver, kind of. And now we can set the variables. So if we want to get the module base address, we're going to need to set the process ID, which hopefully we're going to set with the global variable. And then we want to say request base is true, because that's what we want. And then everything else is going to be false, pretty much. So read false and write should be false. Cool. Now we set the module name that we want. So that's going to be the parameter. And that's it. We can call the hook and pass instructions. So that's going to pass by reference. Call name. Why is it called call name? Why did I do that? Alright. So we're doing the ampersand here to pass the actual address of instructions, which is going to be a pointer to instructions. Cool. Wait, what? Oh. Lol. So we're going to need a ulong64, and I'm going to call it base address, and that's going to store the base address of the function. Classic. Alright, cool. So that's the base address thing. You can use this for any module. So let's say CSGO, you want to do client.dll, you just pass client.dll, it'll get you the base address of that. Or if you pass csgo.exe, it'll get the base address of the process, right? So that's what's awesome about this function. Next, we're going to do the reading and writing, which is exciting. So we're going to use a template for the reading, of course, because you guys are going to be using it for a bunch of different data types. So it's easier when you use a template because it'll work for like whatever data type you want. And I like to use snake case actually. Oh no. Cool. So we're going to make response variable here. Alright, so we're going to need the response and of course the instructions. That's going to be the process ID. So that's going to be size of whatever data type you've passed here. And then we're going to need to set a lot of variables here. So the address is going to be whatever address you want to read. And then we're going to set the booleans. So read is true. The other one's going to be false. I might just copy this and paste it every time. Write is going to be false. And what's the other one? Request base. That's going to be false too. And then the outputs can be the address of response. And then we can call the hook, pass our instructions. Cool. And then return response, which is whatever we read. So that's the read function. So we're going to do the write function now. So we're going to need the address we want to write to, the source address, and This needs to be not like that. Cool. So we're gonna need instructions as usual, and then yeah, I've still got it pasted. Cool. So address is gonna be the right address. So right's going to be true because we want to write. Everything else is going to be false. We're going to need a buffer address. We're going to typecast here. That's going to be right size. Cool. And then we can call the hook with the instructions. And we can return true because it worked, I guess. Cool. Alright, so we've got that. I'm going to make a little wrapper for this function. That's going to use template. And this one's only going to need like 2 parameters compared to 3. And we can just return this function here with these parameters. So that's going to be that. We're going to typecast this. I'm going to say value, right? And then it's going to be size of whatever that is. Cool. All right, so now we have to code the actual hook in the kernel driver to read the instructions. And it should be pretty simple. Shouldn't be too long. So first thing we're going to do here is we're going to typecast the parameter as our structure. And I don't think it's defined here because I put it in CPP, not the H. There we go. So now we have a pointer to our instructions. We can check what we need to do. So first I'm going to check if it's to request a module base. So if that's not false, which means, you know, if it's true, then we're going to get a module base. So here we're just converting it, the module name. Where is this function defined? Alright, so these are the functions we're going to need. We're going to need 3 more functions here. One to get the base, one to read, one to write. So the first thing we're going to do is the get module base one. And this is for x64. So we want to get the PEB of the process, and if that's invalid, we're going to return. So what we're doing here is we're basically attaching to the process. So I guess I don't have this defined. We're going to need a lot more definitions here. I just pasted these. You can just search these on like React OS and then copy and paste them. So we need underscore PEB, RTL user process parameters, the data table entries, and even the PEB loaded datas. So yeah, search these up, paste them, or you can copy it from the video. Alright, so we want to make sure that's valid. If it's not, we need to detach, since we attached already. And now we can loop. Alright, cool. So we're looping through the linked list here. So now we're comparing the names, if we got the right one. Now we can unstack, we can detach. And then we return the base address of the module. And then if after all that, if that still fails, then we need to detach and return. Cool. So that's for the module base. Next we need to do the read and write functions. Gonna need process ID. So we want to validate the arguments first before we do anything, just to make sure the driver went blue screen or whatnot. Cool. So that's where it's actually reading the memory here. It's copying the virtual memory. And we want to check what status is, if it worked or not. Cool. So that's for the read, and then we need to do the so now we need to do write process memory. We're going to do the same checks as up here. Cool, I'm just going to copy that. Then we attach, and we're gonna get some info here. Okay, so if the query failed, we detach and return nothing. Should be false, even though it's going to be the same thing really. But so it's pretty obvious what we're doing here. Just making sure the arguments are right and that we can actually write to the memory. So we want to make sure that, so we want to do a lot of checks on the memory to make sure that we can actually write it, and that it's valid and whatnot, because it's very easy to cause like a blue screen otherwise. Okay, so basically checking all the flags here that would let us write to the memory. And basically, if it's any one of these, then we can write to it. So we're going to do RTL copy memory. And then we can return true since it let us copy. Alright, so that's all the functions. Now we can go back to the hook and use these. Cool. Cool. So that's to get the base, and then next will be if we want to write. So I'm going to do a quick check here to make sure the address is in a valid memory range. okay, just in case in your user mode client you don't do proper checks and then you do pass the address as 0 or something. This will make sure it went blue screen. Cool. Now we can use our function here. Cool, so that's for the writing memory. Next is reading memory, and that should be the last one. So I'm going to do the same check here. And this is going to be very short code here. Already done the check. Alright, so this should be just a one-liner here, because we've already done the function, so... Cool. Then we can return success. Awesome. So that's our new hook function. We check if we want to request the base, if we want to write, and if we want to read. That's all the functions that we need. So I'm going to make a little main function and test it out. I guess for this series, I'm going to be using Rainbow Six Siege for an example, just because it's a lot easier to hack. Classic. Fuck. 4 minutes. Okay, should be fine. So I was gonna test this out on Rainbow Six, yeah. But Rainbow Six is updating, so whatever. Let's see if this takes 5 minutes to code. So I'll just do a little stuff here.
God motherfucking damn.
Otherwise, if the base address is correct, I'm just gonna say yes. Alright, cool. God motherfucking shit. So we're gonna be using now get module base address. I'm gonna test it on Rainbow Six apparently. Hopefully it works. Just wanted to say thank you so much for sticking around to the end of the video. I appreciate it. Hopefully you followed along or you learned something. But if you want the source code from this video or any other video, as well as like the files. So from this series I've been including the driver file and whatever I've been compiling. If you want that, go on my Patreon, $5 a month, and you'll get access to all the source code. I've been doing it for all my videos, so you can see part 1's already there, and I'll be uploading part 2 after this. So if you want the source code as well as the compiled files, you can head over here. You also get a supporter role in my Discord. I want to make sure nothing epics don't want to get demonetized, you know. So I'll open. Fuck, I don't know what to open here. Supporters only. Hell yeah, this looks wholesome. Alright, so you also get a supporter role in my Discord. You can see these guys, they got cool stuff. And you also get access to this supporters only chat in here where people can ask questions and we actually help. As long as it's not actually a a silly question, they can be answered by Google. Also, I want to start something new in my next videos. I want to keep it as kind of like a surprise. I don't know if it'll be I guess we'll see if it works or not. But basically all I need you guys to do is comment down below anything. It could be like a sentence, a word, it could be random, it could be funny, just something random, you know. It could be what you did today, or it could be a joke or something. Just comment it down below and I'll be using it in my next videos. That's all I'm going to say. If you have any ideas for those new series, comment them down below as well. Thank you so much, and I'll see you later.